In earth moving projects where we're doing cut and fill calculations, we're going to use one of two methods to actually calculate this. And you'll usually be told which, and if not, it'll come down to perhaps even trying both. But you're going to use average end area, which is actually what we're going to end up using in this case. But that's going to be used for two consecutive cross sections where you know the area of those two cross sections, and we're going to find the volume based on the area of each of those two cross sections averaged times the length of the distance between them. That's the average end area method. The other is the prismoidal method. In this case, we're going to do this if the two end areas are kind of greatly differ by a lot, or when the ground surface is kind of irregular between the two locations, and you're going to use a slightly different calculation in this case, basically weighting the mean average higher than the two ends, and then you're taking an average, or dividing it by 6 to take an average of those three different measurements. So you're weighting that center average. So in this case, we just have two stations. We're just going to use the average end area method. There's a couple key things that are going to give us clues to that. Again, it's just two of them. That's going to make it easier. But we're going to have to both cut and fill in this area. So we're going to have some positive and some movement of soil. We're going to take some away. We're going to put some back. And so basically we want to do those things one at a time. We're going to deal with the cuts. We're going to want to deal with the fills. We're going to add them up. We're going to see what we end up with as a total. It may be a positive, net positive, might be a net negative as far as soil movement goes. So let's deal with the volume of the cuts first. Again, taking into account that first formula there. So these are given in the question. We're going to be taking away 6 at station 1. This is in square feet, so it's kind of a two-dimensional amount. And then taking away 29 at the second. And the length between them is just 100 feet. It's one station. That's going to give us our answer in cubic feet. So in order to get to cubic yards, I want to divide the whole thing by that number 27. Again, it's 3 by 3 by 3 to get from cubic feet to cubic yards. The volume of the cut between the two stations. Next, let's look at the volume of the fill between the two stations. Again, the length. You may be able to skip some of these steps as you go and you get faster at this, just writing them out for reference. Again, we're dealing with 100 feet between the stations, and that first one there was 29 square feet of fill, 5 for the second. You're going to average those two things out, and again we're going to divide by 27 to get our answers into those cubic yards. That's 63. So what are we going to do next? Well, important kind of point here, you could maybe just be swayed to just add those two up, and maybe there's an answer in your 4 choices that actually is incorrect, where they trap you that. The testing indicates 10% shrinkage could be assumed for all earth moving operations, so we actually want to take that into account for our fill. That fill is going to actually have a shrinkage factor in it. So the volume of the fill times that shrinkage factor is going to be 63 times 0.1 equals 6.3 cubic yards. This is basically additional fill that's going to be needed because we're going to lose some in the value. So alternatively, you could have just multiplied this by 1.1, understanding that 10% shrinkage. But basically, how much earth is going to be needed to add in order to make up for that 10% shrinkage is an extra 10%. So the net excavation, or the volume total, I'll just write net excavation, is then going to be equal to the volume of the cut plus the volume of the fill plus that 10%, so we'll add that back into there. It's it's going to be that negative 64.8 plus the 63 and plus the 6.3 that we were just looking at there. And so in sum it's going to be 4.5 cubic yards of fill is going to be needed to add between the two stations there.